Welcome to a new series, By a Few Degrees, where direction, not chance, writes history. Only on your dose of Wowness.
After 5 heavy episodes in a row, let's talk about something that actually goes right and still comes down to an angle. 2 bicycle mechanics from Ohio spent 3 years camping on a windswept, bug-infested stretch of sand in North Carolina. For one reason, they needed the wind to blow a very specific way. They were looking for a reliable, steady force hitting the dunes at a precise angle. Here's why the most famous flight in history needed the weather to cooperate first. This is day 8 of By a Few Degrees, our palate cleanser after a heavy run, and one of the purely fun ones in this arc. Subscribe if you want the rest of the series, including our 2 cosmic finale episodes coming up. Orville and Wilbur Wright were bicycle mechanics running a shop in Dayton, Ohio. They spent their days solving highly practical mechanical problems. When they turned their attention to human flight in the late 1890s, they approached it with that exact same mechanical rigor. They realized that flight required 2 halves of an equation. One half was the aircraft itself. The other half was the atmosphere it flew in. Success would be a negotiation between human engineering and a specific coastal environment. By modern standards, early internal combustion engines were massive blocks of heavy metal that produced very little power. The engine the Wrights eventually built for their 1903 Flyer weighed nearly 200 pounds, but it generated only 12 horsepower. This schematic shows the 1903 Flyer sitting on flat ground. That heavy, weak engine means the small thrust vector it creates is completely dwarfed by the massive weight of the aircraft pressing down. On its own, the engine cannot move the plane forward fast enough to generate lift. But lift relies on airspeed, how fast the air moves across the wing, not ground speed. If you point the nose directly into a strong headwind, the wings experience a high airspeed, even if the aircraft is barely moving relative to the ground. That headwind forces the lift vector to grow, eventually overcoming the weight. The Wright brothers understood this math perfectly. To supplement their heavy, underpowered engine, they had to find a location that supplied a reliable, forceful wind. For the Wrights, meteorological site selection was a core design tool. They treated the wind as a technical specification, just as critical as wing shape or propeller pitch. In 1900, Wilbur wrote a letter to the United States Weather Bureau. He requested historical data detailing regions of the country with the most consistent and favorable wind speeds. Looking at this map of the East Coast, we can trace the results of that data. The Bureau's records guided the brothers away from their Dayton workshop, settling on the outer banks of North Carolina because of its unique exposure to Atlantic winds. Wilbur followed up by writing to William Tate, the local postmaster in Kitty Hawk. Tate confirmed that the winds there blew constantly. He also noted that the area was covered in wide, soft sand dunes, which would offer a forgiving surface for the inevitable rough landings of an experimental aircraft. If you're enjoying this lighter one after the last few, let us know in the comments. We like knowing when the palate cleanser lands. The Outer Banks were remote and difficult to live in, but the brothers didn't view the isolation as a hardship. This was the moment they finally secured the invisible engine they needed. Wind speed was only part of the equation. The brothers chose the Kill Devil Hills dunes specifically for their topographical elevation. This cross-section illustrates how the dunes acted as a physical tool. Air travels horizontally until it strikes sloped sand, forcing wind upward diagonally. This natural ramp provided a constant vertical boost. Launching into this updraft meant sustained flight required far less engine power. Between 1900 and 1903, the Wrights used these precise updrafts to test a series of unpowered gliders. They spent 3 seasons refining their wing designs and control surfaces against the specific mechanics of the dune's wind. The Kill Devil Hills geography was a quiet co-author of their success, providing the essential lift that the machine alone could not generate. On the morning of December 17, 1903, a biting wind was blowing directly along the beach at nearly 27 miles per hour. It was exactly the aerodynamic boost the Wrights had calculated for. Orville took the controls first, achieving a 12-second flight. Later that morning, Wilbur completed a run lasting 59 seconds and covering 852 feet. It was the first sustained, controlled, powered human flight in recorded history. The testing session only ended when a sudden gust of wind flipped and damaged the aircraft. Their success was a literal partnership with the weather, ending when the wind became too much for the machine to handle. This triumph was about the incredible physics of using one specific wind angle to achieve a path into the sky. It remains the Ark's clearest example of what happens when engineering and environment perfectly align. So even the first flight in human history needed the wind to cooperate at just the right angle. That's our breather for this Ark. Tomorrow we go back to the sky, but a much bigger one. In 1994, astronomers watched a comet break apart and slam into Jupiter in real time, in a series of impacts bigger than anything in recorded history. And it taught us exactly what a differently angled orbit could have sent toward us instead. Tomorrow, we explore the comet that missed us.